Question 3 deals with proof that root 2 is not rational. So if you checked out my YouTube page, 168 of you got lucky. This question has come up, followed by a log question. So let's have a look at the log part. You can look at YouTube for the proof that root 2 is not rational. Part B is dealing with a change of base log rule. Hard to practice a lot of questions on these, but the information is given here. The log of b to the base a, we can change to any new base. You can see here we're going to change them normally to the lowest one, so we'll change them all to a 3 here. And we should be able to simplify it down then and get all in one format. So if we simplify everything in the form log of t to the base 3, let's write everything in this format. So the first one we leave alone. The second one is going to become log. The b, you can see, is here, and the b is the t. That stays up the top. And we give it the new base that we're changing them all to 3 over log to the base 3. This c is the new thing in the equation of a, which is the original base number, and you can see that this is going to become a 2 on the bottom. 3 to the power 2 is equal to 9, plus, following the same rule, the t stays on top with the new base, and the base number comes down to the bottom with the new base, and then plus log t to the base 3 over log of 81 to the base 3. These are all equal to 10. So it might be easier if we let x equal log to the base 3 of t. We don't have to. We're going to get this one. This was in the original sequence, so we're going to get x plus x over 2 plus x over 3 plus x over 4 is equal to 10. So we can solve for x and then let it equal this guy again. So common denominator at 12, x plus 6x over 12. I'll call this one 12x over 12 plus 3x over 12. Just put 112 on the bottom, plus 4x over 12 even. Taking the last one, 3x over 12. Just double checking them all, equals 10. We have a half, we have a third, we have a quarter. So we've 10 and 3, 13 and 12, 25x's over 12 is equal to 10. So that means that x is equal to 120 over 25, 120 over 25. So they don't divide by 4, 24 over 5. So therefore log of 3 to the base t, which is equal to x, is 24 over 5. So 3 to the power of 24 over 5 is equal to t. So we're asked to solve for t. Find the value of t and 3 to the power of r. So this is part 1. C part 1, explain what log 6, the log of m to the base 6 means, where m is a positive real number. Well, if log of m to the base 6 is a positive real number, so it's greater than 0, it means that, well, let's say it's equal to x, just so you can see an equation then. If this is equal to x and x is greater than 0, it means that 6 to the power of x is greater than 1. Therefore, x has to be greater than 1. And what does it tell us about this log? Well, it tells us that this log then is going to be greater than 1. What are they looking for? Let me just double check this reading. And what information does this give us about the value of this guy here? I think it's just that the log is greater than 1. Log to the base m of 6, log m to the base 1 is greater than 1. And I'm actually reading it incorrectly. Probably m is a real number and m is greater than 6. So we have log of something greater than 6. Well, let's just say 7 to the base 6. And it's a positive real number, so just means that x has to be greater than 1, I think. If this is equal to x, 6 to the power of x is greater than 6. That's what they're looking for here. 6 to the power of x is greater than 6. So therefore x has to be greater than 1, kind of what we were looking at up here.